Hey guys, this is my last video. We'll be looking at mathematics scope and sequence, foundation to year 3, statistics and probability. So under statistics and probability, we have data representation and interpretation and chance. The idea of chance doesn't start till year 1. Under data and representation, students are to answer yes or no questions and collect information. So this progression of content knowledge comes quite sophisticated by year 3. So by year 3, students are expected to conduct experiments. They're expected to come up with methods for collecting data and interpreting it. So for this activity that we're doing today, I'm actually suggesting a method of collecting data for the activity, but it's a good idea to really get students to start thinking about their own methods and what would work and why it would work. So with this activity today, we've got our hundreds chart or hundreds board. We've also got a die. So it's just a average 6-sided die. Unfortunately, instead of a 1, we've got a handshake. It's a new Monopoly die, I believe. But what we're going to do is we're going to roll this die as many times as it takes to get to 100. So as we do this, we're going to count along. So let's say for the first roll, we're going to count along and just make a little mark. So from this, we want to understand how many times each number appears and how many rolls it takes to get to 100. Now, something we want to ask our students before we get started is to guess, estimate, how many rolls do you think it'll take to get to 100? Now, in my experience, students hate doing this because they hate to be wrong, they want the right answer, but the great thing to remind students is that it's chance. So as they'll see in the results, no or very few of them will be the same. The outcomes will all be varied. But another reason for doing this is to get students to be really critically thinking about their answers and outcomes. So as you see, there's only 6. The highest number is 6 on a die. So just from our times tables, what we do know is 6 times 10 is 60. So students need to make a guess that's obviously more than 10 throws. 10 throws, we're only about halfway there. So let's say about more than 20 throws. That's if we get all really high numbers. So this is something students should be really considering. If they're giving an answer like it'll take 5 throws to get from 1 to 100, they're obviously not thinking about the aspects involved in achieving this. Their critical thinking isn't working. So if it does come to this, just prompt students. Get them to think about what they're actually doing. Okay, so to collect data, we're going to do a little tally. So we've got 1s, 2s, 3s, 4s, 5s, and 6s. So this is going to be our method for collecting data. So as we start, let's do it. So that's 1. And we colour there. So the reason we're colouring up here is we see how many times we've thrown the dice. Oh, we're not doing very well, are we? Also, this is a counting on. So we're here, 1, 2, 3, 4, 5. We've got to remember to put this here. 5. 1, 2, 3, 4, 5. 6. 1, 2, 3, 4, 5, 6. So students keep doing this. Oh, we have to remember to record that. A 4. 1, 2, 3, 4. So from this method, we can collect this data and interpret it. So how many times did 1 appear? How many times did 6 appear? How many times more did 1 appear than 6? How many rolls did it take to get to 100? All these kind of questions that you can ask. How close was your estimate to the actual number? Did anyone have the same number as you? If they had the same number of roles, how did that differ to the numbers that did appear? All these kind of questions that come up in analysing data. Anyway, that's just one little activity I've come up with for understanding chance and representing data. Thanks for watching. I'll see you next time. Bye.